Alright, we are now testing the multiplier. The yellow line, Vn, is a, let me double check, 100 hertz sine wave going from -1 to +1. And the output, you can see, is going from 0 to almost 1, and that we've doubled the frequency. Now, if the input was a 1 volt, we should square that and get 1 and divide by 10, so we should get 100 millivolts. But you can see we're getting 111 millivolts, right? And in fact, that's partly due that the power supplies at 5 and 5, -5. The negative one needs to actually be set a little bit higher to something like 6.8, right? And then we actually get a lot closer. The data sheet says you need plus or minus 18 volts. I'm probably getting away with plus or minus 5, and sometimes I'm able to even get more than that, or less than that. But there's a problem, is that when so for my example, the quadratic integrating fire was going from 1 to -1, but in your example you're going from 2 to -2, and we're going to see something interesting here, is that one peak goes higher than the other. And so you can either, this stops at about 2.4 volts peak to peak, right? You can get away with 2.7 peak to peak, so you can rechange the project so that's your swing. Or if you have to, you can just increase your negative rail to about 6. And if we recall, in that circuit, nothing else is depending on that negative rail. It shouldn't affect the rest of the circuit. And so we can see a V peak of 2 volts, we're getting almost 400 millivolts, which that's pretty close. So I'll leave it to you, but that's if you're seeing something weird, right, you just might have to change your negative power supply to a little bit bigger, and probably results will vary. You might have to change your positive power supply for something, although at that case so many things depend on the positive, so many references, that it's probably just better to just change the output swing. But we have now testing the multiplier, and that's my input, which then I will just solder into the input of to the output of the second op amp. And you can see this is the feedback resistor that then I'll put back into the input node. So the next thing about this testing I just wanted to show you was the X and Y. So if you click menu, zoom, and then X and Y, alright, you can see the X squared function. And if you do acquire and go to high accuracy, you can see. And I'm just going to lower the negative power supply, and you can see that it's getting really warped. All right, but notice the positive side doesn't go as high as the negative side. All right, and so I'm just, so that at about 6 they're even. Anything that seems like about 6. But that's pretty cool.